talking about those particles that are emitted. I mentioned that you have the alpha particle, and the alpha particle, all right, the symbol is like this. That's the alpha particle, and it has a it's actually helium particles. So that is helium particle 2, 4. Now what does the 2 and 4, what do they represent? The 2 is the atomic number of helium, 4 is the mass number of helium. I will tell you the implication of that very shortly. For the beta particle, this is beta particle, this is the symbol for beta particle. Alright, we said they are electron particles. So this is your electron. Okay. Now we are going to know the mass number and the atomic number. Now focus on this very well. You remember that when you have an element like this, let's say element X, and I have a number at the bottom here, and I have another number at the top. This number at the bottom is referred to as the atomic number, and that atomic number is the number of protons present in an atom of an element. So this A is the number of protons, okay, while the Z is the mass number. Okay, it's called the mass number, and this mass number is the number of what? Protons and neutrons. Proton plus neutron. So now if I'm going to determine what will be the atomic number of electron, of this electron, the mass number. Now let's start with the mass number, which should be up here. Mass number is number of proton plus number of neutron. But an electron does not have neutron number. It doesn't have neutron, it doesn't have a proton, because it's a particle on its own. If you look into the atomic structure, you will see that inside the nucleus of the atom there are 2 particles, protons and neutrons. Then electrons are on the shells or the orbitals outside the nucleus. But so for us to get the charge of electron, or to get the mass number, which is meant to be up here, is number of proton plus neutron. So but because electron does not have number of proton and neutron, it's going to be 0 proton and 0 neutron. So here will be 0. So electron has 0 mass number. Then here the number of proton is supposed to be down here, and you remember for a neutral atom of an element, the number of proton and the number of electrons are the same. So if electron electron does not have a proton number, but it's an electron on its own, so it's going to have 1 electron, so it's going to be 1 here. Now there are 2 variants of this beta particle. We have the positron, which is positively charged. So if it's positively charged like this, it's called the positron, okay. But if it is negatively charged, that's the electron minus 1, 0, it is called the negatron. Okay, negatron. All right, it's called the negatron. Now having said that, the next thing we talk about is the gamma particle. So for the gamma rays, you remember we say it's not a particle. So for the gamma ray, the symbol is, so this is gamma, and it is like this. All right, so it has no protons and it has no electrons, or rather it has no mass number and no. So gamma ray, it's 0 up, 0 down. 0 up, 0 down means no mass number, no atomic number. All right, because it's not a particle, it's a radiation. So these are the 3 particles that we have in when we are dealing with radioactive elements. So for the alpha particle, we said they are helium particles. They have atomic number 2, mass number 4. All right, for beta particle, if it is positron, is +1 down, 0 up. All right, if it is negatron, beta particle, -1 down, 0 up. Then if it is gamma rays, it is 0 up, 0 down. Now let's now see how do they apply all of this in solving problems. An element, let's say here is 93, here is 235. All right, the atomic number is 93, the mass number is 235. They now give you another element, they ask you to find the x, but they now tell you that it emitted a particle, let's say the alpha particle. If it's alpha particle, that is helium particle, so you have 2 down, 4 up. Now the sum of the mass number on this product side must be equals to the mass number on the reactant side. The sum of the atomic number on the product side must be equal to what you have here. So for me to get here now, what will I add to 2? That will give me 93, that is 91. So here will be 91. 91 plus this 2 is 93. What will I add to 4? That will give me 235. It's 231. So that means for this x now, the atomic number is 91, the mass number is 231. Are we together? So that makes up the. Now if they give you the same question, let's try another question. 93, they might tell you 2 alpha particles and maybe 1 beta particle was emitted. Then they now ask you to find the value of x. All right, so you were given uranium, all right, 2 alpha, 1 beta, and x. You were asked to find the x. It's very simple. All you just need to do is, this alpha is helium particle, so you are going to have uranium or U235 93. It will give you 2 alpha will mean helium particle, which is 2 4, but now you are now having 2 pieces of it, all right, plus 1 beta. If it is positron, then it's going to be plus 1 and 0, then plus x. So how do you know whether it is positron or negatron? Just check the option, you are going to see it there. You will see this one will tell you whether it's a positive or negative depending on the sum. So for this helium, 2 multiplied by 4 is 8. 8 plus 0 is 8. All right, if I remove 8 from 235, I will be left with 227. All right, 227. Then here, 2 multiplied by this 2, that is 4. 4 plus 1, 5. If I remove 5 from 93, it's going to be what? 88. So this is 88. So this unknown is x, which has mass number 227, atomic number 88. Now we are going to try a typical JAMB question. Radioactive series. Now you were given this series, you have 9235, the atomic number is 92, the mass number is 235, the M 93 235, the N 94 235, then you were given this symbol. 90 is the atomic number, 227 is the mass number. So all you need to do, this is very simple. What am I going to add to 235 here that will give me this 235 here? What will I add to 92 that will give me 93? So it's going to be 1 down, 0 up. Okay, so what kind of particle is that? That is beta particle, and that is the positron beta particle. So it's plus 1 down, 0 up. So if I do plus 1 down, and 0 up, if I add the 1 to 92, it gives me 93. 0 to 235, 235. So what will I add to this 93 that will give me 94? Is plus 1. What will I add to 235 that will give me 235? 0. So this is still another beta particle. Plus 1, 0. Are you seeing it? So 0 plus 235 is 235. Plus 1 plus 93, 94. Now here, what will I add to 94? That we have 90 here. What will I add here? So in this case, for everything to balance up from here to here now, that means I'm adding if I remove 227 from 235, that is 8. Okay, that is 8. Okay, so that's 8. That is 8. And that's already suggesting to me that that's helium particle. 90 from 94 is 4. So this is automatically 2 pieces of helium particle, because helium particle is supposed to be 2 4. So that means this is 2 pieces of helium particle, 2 of helium particle. Helium is 2 4, but I have 2 pieces of it. Okay, let me have some brackets here. So 2 pieces of helium particles, or 2 molecules. All right, it will give me this. So 2 times 4 8, 2 times 2 4. If I add 8 to 227, I will have 235. If I add 4 to 90, that's 94. So that means the last one here is 2 alpha particles. So it's beta here, then 2 alpha. So the answer is beta, then 2 alpha. Those are the particles that are emanated from that first equation. Now the second one, it says sodium with atomic number 11 and mass number 3 plus X to give F with 10 and 20, that's fluorine, then helium 2 and 4. What is X? Remember the rules is the total mass number here will be equal to the total mass number here. The total atomic number here will be equal to total atomic number. So what will I add to 23? 20 plus 4 here is 24. What will I add to 23 that will give me 24? Is 1. So here is 1. Then 10 plus 2 here is 12. What will I add to 11 that will give me 12? Is 1. So what particle is 1 1? It is not neutron, it is not alpha, it is not gamma, it is not beta, it is proton particle. Now I will quickly talk about the other particles apart from alpha, beta and gamma. So there are 3 particles that they can talk about. They can talk about proton particles. What are proton particles? Proton is just hydrogen particle with 1 atomic number and mass number 1. This is one of the isotopes of hydrogen, which is called protium. So this protium has 1 up, 1 down. So anytime you have something like this that is having 1 up and down, it is a proton particle. They can ask you. Another one is neutron particle. Neutron. Now, how do I get to know the mass number and atomic number of neutron and electron? A lot of people mix it together. You see why they mix it now. For neutron, I will write my hand here. You remember mass number is up, atomic number is down. And atomic number is the number of protons. So a neutron does not have protons, so the atomic number will be 0. But a neutron is a neutron on its own. So the mass number is usually neutron plus proton. But because this neutron does not have a proton, it only has a neutron. So it will have 1. 1 plus 0 proton. That is 1 neutron. So this is the symbol, or this is how to write for neutron. It has 0 down at the atomic number, 1 up as the mass number. That's a neutron particle. While for electron particle, electron is E. Now, what is the number of protons that electron has? None. What's the number of neutrons it has? None. So the mass number of electron is 0. Why the atomic number? Atomic number is the number of protons, but there are also equal number of proton and electron. So that means because it's electron, it has 1. But this time around, it's going to be -1 because it's carrying a charge. So if this electron is negatron, it's this. But if it is positron, it is +1 0. And these electron particles are the beta particles. So the beta could be positron, it could be negatron. They will indicate whether it's positive. They put positive here if it's positron, they put negative there if it's negatron. So these are the 3 other radioactive materials majorly from artificial radioactivity. These are majorly the other 3 apart from the alpha, beta and gamma. These 3, take note of them.